All right, guys, in today's video, we're looking at a very specific crank no start type condition. If we turn the key on here, you'll notice the security light in the upper right. Now, this is normally something that just does a lamp test and then goes out, but we can see it's actually staying on. In the case of this engine being a diesel, it's staying on during the glow plug cycle, and it should have already shut off by now. So that's one condition on this crank no start for this video to apply to you. The other is if we pan over and take a look at our Tech 2 and our scan tool, and we take a look at the diagnostic trouble codes that we've got, we'll find that we've got a particular code here that is applicable to this problem, U1000, that you can see up here in the upper right. Now, a U code is a communications code on the Class 2 serial bus, and so we've got a problem where that's failing. So we've got a security light on, we've got a U1000, and we can do a crank, but it's a no start, but it's a very specific kind of crank no start. The engine starts and stops within a couple of seconds. So we know we've got a vehicle theft deterrent problem. If we pop out, what we're going to want to do is we're going to kind of confirm our observation by running a Class 2 diagnostic circuit test. So we're going to come over here and we're going to look at the message monitor. And sure enough, we see that we've got the ABS module active. We got the powertrain control module for diesel / vehicle control module for gas active. We got the automatic transfer case module active, but there's no EVO Passlock module in the list. So that module is offline and not reporting the OK to start code to the VCM or the PCM, and that is why we're not getting a start. So let's go debug that. All right, guys, to get access to this EVO Passlock module, the first thing we're going to need to do is take this lower trim piece off. There's several 7mm bolts, one here below the parking brake release, one here, and one here, and then one right over here in the corner. We'll do those, and then we can take a trim tool and we can pull this piece off, and then we can go after this piece that's behind the cigarette lighter and power accessory plugs. All right, guys, after you get the plastic trim off, we got to take this metal bracket off. I already took the two 10mm off here. There's two 10s on this side as well. Just remove these four 10mm bolts, and you'll be able to drop this metal bracket. All right, guys, after you get that lower cover off, then we've got this center piece here. Take the ashtray off just by pushing the release lever here. That comes off. And then either side, there's two of these little push pins. There's two here and there's two on the other side. They're all the same. You take a small flathead screwdriver and work these out just like this. Now these are real brittle, so be careful with them. They can break off. Now sometimes it's enough just to get them pulled out like that. Sometimes you have to pull them out the rest of the way. We're going to do the two on the other side, and then we'll pull the rest of this piece off. All right, after you get this out of the way, you got another 7mm bolt right here. You can go ahead and take that off. It'll give you some more flexibility to get your hand up behind here. The location of this EVO Passlock module is right behind here. So let's see if we get you a view with the camera now that we got this out of the way where we can get in here. So guys, this particular salvage yard vehicle, somebody's already taken out the radio and everything, and that works out great for us because it gives us a perfect shot of this EVO Passlock module. So these are the two front tabs on that module, and these two guys here in the back are the locking tabs. All right, and so if I reach my hand back here, what I'm going to do, if we zoom in and see these little locking tabs, I'm going to go pull those down. Try to pull those down. Now, I'm not going to be able to get it with this angle from filming it to you here, but all I was trying to do was pull it down like that. That's how we get this guy to let go, and you can see him right here. Right, there he is. So I got to rotate him around and unplug him, and we'll pull him out. All right, guys, so this is why we took that 7mm bolt out, right? So we've just kind of rotated the module down. In this position here, you can see the plug. This way we'll be able to disconnect it and pull it out. Now, if you find you need some more room, you can bend these small tabs up for this heatsink piece that's under here, and that'll let this guy come off this bracket, right, if you need more room. And then when you put it back, just remember to come back up and bend these little tabs back to retain it again. Just like that. All right, if we consult the service manual and we go to the theft deterrent section, what we're looking for is a schematic to see what all this looks like. So now that we've got it out, here's a view of the opposite side to what I showed you pulling this out of the salvage yard vehicle, right? So I showed you these tabs coming up in the front and these two locking pieces coming up in the back. This is like a view from the back of that same piece. All right, this is what I'm looking for. One of these circuits. This one will do just fine, the diagnostic check. So here's the EVO Passlock module. And what we see is the Class 2 serial data. Since we can't see this module and talk to it, we can see it's got B4 as a purple wire running to a splice pack S280. And then it branches over to the automatic transfer case module that we do see and we can talk to. It branches over to the EBCM, or the electronic brake control module. We see it and we can talk to it. Then it branches down to either PCM, powertrain control module for diesel engines, or vehicle control module for gas engines. And we can see our PCM in this diesel and we can talk to it. So the whole bus is not down. Just this section here potentially is down. We can obviously talk through the diagnostic link connector, which is over here. So they show the whole where we plug in the scan tool, and that comes in over here. So that whole part of the circuit's working. We just can't talk to this guy. So in order to figure out if this guy's functional, we're going to go verify that B1, the ground, is okay. B3, ignition voltage. B8, battery voltage is all okay. So if we take a look at the actual connector, we can see some of these things we don't really need to check, right? Of these 16 pins, 3 of them aren't even used, so now we're down to 13. 2 have to do with the position of the steering wheel, because this module does 2 jobs. It does Passlock theft deterrence, and it does electronically variable orifice power steering solenoid control. This position sensor at the base of the steering wheel is for the EVO, so we don't need to worry about that. So now we got 5 of them knocked out, and we don't need to worry about the solenoid output and inputs, so that's 7 of them knocked out. So we almost got half of them knocked out just like there. Now we can knock 8 out because the security indicator lamp output is working. So that's functional because the light's lighting up. So half of them we don't need to check. So all we're going to do is check B1 to verify that the ground is working from the engine computer. We're going to verify that we've got battery voltage on B8 with the ignition in the off position, because this is straight up battery voltage. And then we want to verify that we've got voltage when the ignition switch is turned on, and it should also be battery voltage. So B1, B3, and B8 would power up the module. B4 is the serial data line for the Class 2 communications. That's the line that we were looking at. And we're going to verify that we have continuity between B4 and pin 2 of the DLC. Right? So going back to our schematic diagram right here, so pin 2 of the diagnostic link connector, we're just going to verify that we have no breaks in continuity from here to B4. And if all those check out, then we know that it's not likely to be the harness. So let's go ahead and go underneath and run these tests. There's another test we might do relating to this reference voltage feed on A5, just to make sure that it also is 12 volts, but that's about all we could do to check that we don't have a harness problem. All right. Let's remove the module by depressing the blue tab and pulling out the harness. All right, so there's our module. Whoops. This one is going to be a 162-649-65. So the 6.5s are for 3/4 and 1-ton trucks or diesel trucks. It'll end in a 55 if it's a half-ton truck, and that's a 98 to 2000 number. 97 might be different. I'll put all of these down in the links in the description as usual. All right, so let's keep going and get our harness now. So you guys, if you look in here, you should see the harness in my hand here. It's kind of a cyan color, and there's the blue locking tab that holds it on to the module. So I'm not going to be able to get you in here to show these tests, but this is the connector that you were seeing in the service manual. And you can see the colors of the wires to match what's in the service manual if I twist it around here underneath. And that's how you're going to be able to verify the the different voltages that you have. All right, guys, I just had to move the camera here for a moment so you can see there's all your colored wires behind there, and that'll match what you see on that page I showed from the service manual. So you can see, for example, the black with the white stripe right there, right in the front, that's our ground wire, B1, and then all the way in the back we can see the orange, which is B8. So we're just going to go do these measurements that I talked about and check it out, and then we'll come back to the next one. All right, let's do this first test. Let's see if we got battery voltage on pin B8 to ground pin B1. And it looks like we do. So that's a good test. So now let's get set up to do the ignition test. All right, B3 to B1 with the key in the on position. And again, we're getting battery voltage. So let's move on and check the data link connector. All right, so now we'll go from pin B4 of the Passlock module harness to DLC pin 2. And we have tone, which means we have no break in the serial data line. All right, so what do we know? Well, we know that B8 battery output is good because we got battery voltage. And we know that B1, black-white, engine control module ground is okay. And we know B3, pink, the fuse output when the ignition is in either the on or the crank position. We got battery voltage there. And of course that means we don't have to bother testing the fuse because we've got power there. And we know because the light's on, just as a side comment, we know that we have B2 working, which is yellow, which is the indicator lamp output. So the module has power, ground, and apparently a working communication bus on B4. We're going to do one more test on B4 just to verify that even though the line's not broken, it's not got any noise on it. And then after that, what we're going to switch to is there's a diagnostic in this section for a situation where the engine cranks but does not start. Now, this won't totally apply to our situation because this assumes that you have communication to the Passlock module, which we don't. But there are a couple of tests here that are probably worth running. And one of those tests I'm going to look at running is this one here on number 3. We're going to take a digital multimeter and we're going to measure the voltage from the module connector terminal A5 to ground. We're going to verify it's within a battery voltage range. And if not, they're going to tell us to go take a look at seeing if that's being grounded out for some reason. Now this particular test up here, this step determines if the Passlock sensor power is available at the module. If that circuit is shorted to ground, you're supposed to get a code. But we've got this problem here where we have no communication to the module. So it's possible that if we don't have A5 at all, and A5, if we go back to our picture here, A5 is the red-white reference voltage feed. It could be that if we don't have the feed, the module will not respond and communicate on the bus. So we're going to see if we have a problem getting this reference voltage feed. That's really the last thing that should be preventing the module from communicating if we don't have any other... I mean, if we go through all this and it's fine, then we're going to have to condemn the module. The solenoid inputs and outputs for the EVO are not going to prevent this module from communicating. The steering wheel position sensor inputs are not going to prevent it from communicating. And the sensor from the Passlock, which is both the sensor return, the 5-volt reference, and the directional sensor signal, these are not going to prevent the module from responding on the bus. They may prevent the vehicle from starting, but the module will be there and it'll be a standard Passlock problem. Right now we don't have any communication with the module, so let's go do these other tests. All right, first thing we're going to do is we're going to put our oscilloscope on pins 2 and pins 4. So that's our signal line and our ground line. And all we're going to do here is we're just going to monitor that we've got regular occurring traffic, which says that there's communication going on the bus, which is to be expected because the scan tool is able to talk to the other 3 modules just fine. Now we'll do this same connection over on our Passlock module harness to verify that there's still good communication coming across that line. All right, now we're doing connector B4 to B1. on the Passlock module harness with the oscilloscope, and we still see good communications. So there's nothing wrong. All right, so we've got power, we got ground, and we got good communications. So now let's go do this diagnostic here. Let's go connect terminal A5 to ground and see if we're getting battery voltage.
Okay.
All right, A5 to B1. And we're just getting random garbage. So there's our problem. So we do not have a 12-volt reference feed coming into the Passlock module. Just go ahead and make sure that it's not user error here. I'm going to manipulate the probes a little bit. Redo the test a couple of times here. And I will also just test it on the ground of the frame of the instrument panel. And we are getting nothing. All right, so we found our key problem. So let's go see where the troubleshooting guide takes us next. All right, so this test failed. And so they suggest that we go to diagnosing B2947 if this particular test fails on the diagnostic tree for engine cranking but does not start. If we go over to 2947, you can see the first test they're going to want us to do is same pin A5 to ground, but this time we're going to do a resistance check. We should have no resistance because this should not be a grounded connector. So we're going to make sure that we have, an open, infinite resistance on this. If we don't, then we're going to go down to step 4, and we're going to disconnect the C266 connector. This is basically the ignition switch module connector. And then we're going to repeat the test. And that's going to help tell us, is this a problem with the harness going to the Passlock module, or is this a problem with the ignition switch module? All right, A5, and we're going to try to B1. We're going to see what resistance we get. It looks like we got 0L. Not getting any change. We'll go ahead and try it on the metal of the instrument panel. It's still getting 0L. All right, let's go see what this test tells us to do next. Okay, we got 0L. Resistance was in the specified value. Go to step 3, replace the EVO Passlock module. All right, so we went through the whole tree, and it says the module's bad. So now we can be sure that's the right thing to replace. All right, we've plugged in our module we picked up from the LKQ salvage yard. Let's see if we get lucky. And voila, there's our VTD EVO module, correctly responding to pings. So now what we've got to do is we've got to relearn this module, and then the engine should start. So let me go get set up to do the relearn procedure. All right, so I printed out the Passlock reprogramming learn page out of the service information from GM for this particular model year. We're going to ensure the ignition key is in the on position, and we're going to clear all DTCs. Then we're going to go down to this page here. We're going to momentarily try to crank the engine, but we're not going to let it, I'm not going to attempt to start it. We're just going to turn it to the crank position, let it go so it stays in the run position, and we're going to let it sit for 10 minutes. We're going to watch that security indicator on the dash. And we're going to make sure that let's see, we don't have this sensor, so we should not see this flashing. But we replaced this module, so it should flash for a few seconds and then remain on for the entire 10 minutes. And we can skip these other things because we didn't touch the engine control module. So now step 5, it'll transition from flashing to on briefly to off after 10 minutes if the ignition key is left in that position. At that point, when it goes off, we're going to switch the key to the off position, and we're going to wait 10 seconds. And then we're going to repeat this dance 2 more times. So we're going to end up spending about 30 minutes on this relearn process for this older vehicle. Newer vehicles, we'd be able to use the Tech 2 to speed this up, but apparently this one isn't got that capability. And then after that 2 more times dance, then we should be ready to have the special passcode from the Passlock module to the powertrain control module learned, and the vehicle should start the next time we attempt to crank it. So let's go in and go after these DTCs first, see if we have any. We probably only have that U code because we never did have any others, or we may have something new to go chase. Let's go see. So we're going to build this vehicle. Actually, I was too quick on that one, so let me go back. This is a K. Now we'll go in here. 4-speed automatic, DTCs, DTC information. And what do we got? We got to turn the key to the run position. So we've got this loss of communications code, which is a new one, 1192. So hopefully that is a good code. Let's clear that out and make sure it doesn't come back. Okay, that's clear. What do we got now? No codes. Okay, let's be sure. We'll take the key off. Key it back on. No codes. Fantastic. I'm going to pop back out just to be super sure. We'll go back into our diagnostic check. Okay, there's our guy still sitting there active. So now we're ready to start this dance. So we don't need the scan tool anymore, unfortunately. So let me get everything set out of the way and we'll start this 10-minute countdown I'll show you. All right, guys, let's start this dance. If I turn the key to the on position, we can see the security light is flashing the way the bulletin told us it would be. I've got a little timer here set for 10 minutes. We're going to go ahead and start this dance, right? So the dance is to momentarily crank the engine, then release it to the run position, and then wait the 10 minutes. We start our timer for 10 minutes, and we'll come back when our security light is out. All right, so about 2 minutes or so in, the security indicator has stopped flashing and it remains on, which is exactly what we want to see. That's what we saw here. If we kind of step down, it told us that it will flash for a few seconds and then remain on for the remainder of the 10-minute duration. So everything's going the way it's documented so far. All right, now we're going to turn it off for 10 seconds. There's our 10, and start it again. And we'll start this whole dance for another 10 minutes. All right, folks, last 11 seconds here. 5, 2. Okay, we've got our 10 minutes. We start our last 10-minute cycle. Five seconds. Okay, we got it off. And now she should start. But we're going to go ahead and wait that 10 seconds. And there she goes. All right, so we fixed that problem. Now let me show you what's inside these units and go over the torque value to reassemble it. All right, so like I mentioned earlier, the 55s are for the half-ton trucks, and the 65s are for the 3/4 and 1-ton CK trucks or any CK truck with a diesel engine. So what's inside one of these? Well, we can, let's see. We can pop this back piece off first, it looks like. Now there are some people that rebuild these because it's very hit or miss to pick one up at the salvage yard like I did. Since I needed a 3/4 ton one, they're kind of rare. But I'll leave links in the description for that. And then with that off, we should be able to pop this one on the front. There we go. And it should just be a little board in here. So are these things repairable? Well, yeah, technically they are. We look on the other side. All we have is a couple of surface mount resistors and a few surface mount capacitors. This is kind of like a hybrid design. You know, it's in the transitionary period. There's some surface mount technology, but most of it's hole, pin through hole, dual inline package type technology. So we've got several transistors up here. 1, 2, 3. There's another transistor in a different type of case. This processor would probably be unobtainium to repair if that's what was wrong. Diodes, resistors, capacitors, a couple of chips that probably are EPROMs, if I was to take a guess. So electrolytic capacitor, looks like another maybe electrolytic capacitor, or maybe a coil. Can't really, yeah, it's coil. So all of this stuff is relatively repairable. Problem is there's no schematics, and there'd be no way to figure out what the difference is. Now, if we open up the one for the half-ton truck, I expect it to look absolutely identical, and the only difference is the software that has been programmed on the EPROM is my guess. But we'll open it up to see. I've never looked inside one of these half-ton ones. So we'll do this together. And pop this same connector off the end here. Just be gentle with them if you're going to try to repair them, because they can break off. And so, looking at it, it looks pretty much identical. No difference really at all. Just taking a quick glance here, same number of diodes, everything looks the same. Even the same circuit board part number, right? So these are identical. It's just the contents of these chips that would vary. And when you go to these rebuilders, they go through and they'll make sure that the capacitors and the resistors and the diodes and the transistors all check out. And they probably sort through and make sure that there's a good CPU on here. And that's what they do to rebuild these. So I hope that information is useful to you to see what's inside one of these. Let's go button her up and be done with this. All right, guys, we got everything put back together and buttoned up. Those 7mm have a torque value of 18 inch-pounds, just, you know, snug. You don't want to go crazy and crack the plastic. Make sure you get your push pins back in when you put this power module piece back on. If you happen to have lowered the heat sink on that device that sits right about there, make sure you twist those metal tabs back to retain it like I showed earlier. And the 210s, or the 410s rather, that were behind here, you know, it claims that foot is 62 inch-pounds, 62 inch-pounds, but I don't like going that tight on any of this stuff going through plastic, so I just did snug on that as well. Anyway, I hope this helped you out in solving this U1000 crank no start type problem and replacing your EVO Passlock module. If you got questions or comments, leave them below. I'll try to help. If you found this video useful and it saved you some time or money, pay it forward and hit that like button. I'd really appreciate it. And as always, thanks for watching.